All right, welcome back. I got a little bit of time here, so I'm going to try to close out the 103.2 in a part 4. So here's where I left off. So I left off at the second guided exercise, which is explore your local slash etc slash psd file with grep, sed, head, and tail commands per the tasks below. All right, so let's do that. So the first question is, which users have access to a bash shell? So we'll try that first with the just the how about the grep command? So grep password. See what that does. So now this shouldn't work because if we look at the syntax of the grep command with dash dash help, we can see that it's um, a pattern and then a file. So we're not searching for a pattern. So let's try it again, but we'll put in a regular expression here. So any character, zero or any number of times. So there we go. We've got matches now. Um, all right, let's just use the cat first. Oops, and it looks like we've got no. So grep, you can use grep to search through your file system as well. It's not just to search through files themselves. So right now my present directory is this. If I do an ls, I've got these files here, so I can use grep to search for let's say cat in my ftu .txt file, and looks like I don't have any matches here. So let me look at that file more. Oh, that's right, because I swapped it out with sed to dog. So let's search for dog using grep. There we go. We've got 4 matches there. But in addition to doing that, you can search for files. So let's use grep to search for every file in this directory that has the word text in it. So we're going to do search txt and then this dot here to I might need to give it a switch to do that. Oh, okay. So you have to give it so I'm not telling lies. Sometimes I do tell lies on this channel though. So uh but in this case I am not. So you can do dash G, but then you need to specify how you want it to handle a directory. So you can have it read it, recurse, or skip. Okay, so this makes sense. So if you have it read it, so we're gonna go with that. Read. Uh, 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 okay, so invalid argument dog for dash dash directories. Arguments are that. So let's try read. Um, okay, and then let's do user gposh dash read, and then we'll do text. Oh, it's home, not user, and it's a directory, but that's like I know it's a directory. That's the point. Uh, You know what? Let me use the AI, because the AI is wonderful. All right, and there's the just the output from the terminal in there. So it seems like what you're trying to do is use the grep command to search for a pattern in files or directories. However, there's some issues with the syntax you're using. The -d option in grep is used to specify how directories should be handled during the search. The valid arguments for -d are so you do need the quotes. You do need the quotes. Yeah. So let's just see if that fixes things. So we'll do it with a -e first, D first, and then we'll wrap that in quotes, single quotes, and still a problem. So, it looks like I don't need to. I actually don't need the -d maybe, so maybe that's the problem. Let's try that. Nope. Okay. Oh, you know what? I have an extra parameter here. So let's say, can I use grep? And well, I'll just have it speak to it. Can I use grep to search for files in a folder, or is grep only used to search the contents of a file? Okay, so the grep command is primarily used to search for patterns within the contents of files. It is not designed specifically for searching file names or directories. If you want to search for files in a folder based on their names or other file attributes, you can use other commands like find or ls. So to search for, yeah, so I tell lies on this channel. This was a big fat one. Grep is used to search for patterns within file contents. If you want to search for patterns within directories, if you want to search for patterns of file names within directories, you would use find or ls. So I will follow along with the example for find. So find, and then in this home directory, and then -name, text, Okay, so we can see that that was kind of strange. It didn't do what I expected it to do. So then the other thing we can do is ls, and then put a pattern in there. So 0 more instances of any character, txt 0 more instances of any character. There we go. This is the way to do it. So you can have a regex here. This in regex means 0 more instances of any character. So we're gonna match for 0 more instances of any character, which we found all the way up through here for each of these. And then we're matching text, which we found here, and then 0 more instances of any character. So this is what this is the answer you would use, ls, for that. You wouldn't use grep. Grep is for reading the contents of files, not for searching through directories. To do that, you would use find or ls. It looks like ls is the more straightforward way to do it. So I do tell lies on this channel, so just be aware of that. Alright, so which users have access to the bash shell? etc password. So they would be the ones with bin bash. So Let's use grep. So we're going to do cat pipe grep. There we go. So the root user, the user I'm logged in with now, gposh, and then the GNS3 user. Now let's try using it without cat. And there we go. We got the same results. We did the expression, and then we did where to search, and we got the same results without having to use two applications, which would, in a script, significantly slow things down. All right, so the next part of this second guided exercise, your system has various users that exist to handle specific programs or for administrative purposes. They do not have access to the shell. How many of those exist in your system? Okay, so one really easy way, we can do this same command, -v, and then we see the ones that don't have access to the shell because they don't have access to that bin bash. And then the question is how many exist. So we can pipe this through this counter, and then we want to know the lines. So the and the command is WC, not WD. It stands for word count. So now we can see that 31 of them exist on my system. All right, the next question: how many users and groups exist in your system? Remember, use only the /etc/password file. So users and groups. Okay, so and we can do a man on etc password. PISWD, right? Yeah, there we go. The manual page. Okay. Anyway, I mean, I know what is in there. Oops. There we go. So the group is here from what I understand. This is the user. This I'm a bit, my memory needs to be jogged on that. So let's jog it. Let's go to the AI. We'll say explain the syntax of the file. And it's got to think about that a bit. I guess its memory needs to be jogged as well. So okay, we finished this first one exercise. We're on the second one. So how many users exist on your system? So we got an answer for this one. So how many users and groups? So users and groups. That's interesting. So this is the group from what I understand. But we'll see that. Yep, it's the username. Then it's the password, which is hashed. So the location of the password isn't going to be so easy as to just see it printed out right here. So it has this X that shows that it's stored in the etc shadow. So if we do cat etc shadow, we need a sudo here. Okay, so now we see all the passwords in their plain text form. Well, you know what? I don't see. It looks like they're hashed, so we see the hashed version, not the plain text version. Thankfully. Okay, then we got the user ID, the group ID, login shell, home directory, user info. So we're looking for these user IDs and these group IDs, I believe. So this is the user password, user ID, group ID, and then the user info, home directory, and then login shell. So we're looking for these two numbers here, and we want to get them using only that file. So how many exist? I guess you would just try to find the highest number here. Oh, but you know what? It's not. That's interesting. I don't know that one. I guess I'm good to just go look at the answer to that, learn something new. If a lot of this stuff is on the test, that's not going to be fun. Okay, so which users have access to the bash shell? Let's see what I did and compare it to what they did here in the answer. So what I did, and I'll run it again, is I did grep, and then I did so I did it here in command 2078. All right, and the command was grep /bin/bash space /etc/password. That's quite a bit different than the way they did it. So let's try it the way they did it. Okay. And okay, we got different answers here. So we used a different regular expression. We added another match character. That's this colon here. And then we added a special character here, which says start looking for this match at the end of the line. So we've got, actually we've got the same three matches here. Okay, good. Yeah, same three matches. So we started from the end of the line this time, basically matching backwards. And then we found everything down here, including this. So that's another way of doing it. As they said, there's always multiple ways to do the same thing in Linux. Okay, so we will improve this answer by only displaying the name of the user that utilizes the bash shell. Okay, so this makes sense. They want you to do extra things using like the pipe character. So now that I know that, I can probably go back and try to figure that out. But dash F1. So now we just got the first one. So the D, I'm guessing, stands for delimiter. It's kind of like the Python split function. So if we take a look at these files, we've got these reoccurring colons. So those serve as a delimiter between the fields. So then the F, I'm guessing, stands for field. So the delimiter is going to be a colon, and then the field we're going to choose is the first field. So let's see if we can use the delimiter. And the delimiter, well, let's see if we can use another delimiter. Let's use the / delimiter. There we go. And then let's get the second field, F2. There we go. And now we've got everything from here to there. So that's how it works. It kind of works like the Python split function, if you're familiar with that. It does not include the delimiter in its results. And then it splits it into different fields. So if we go back to using the colon as the delimiter, which should be easier, now we can get field 2, field 3, all the way. We could probably even use field -1. Nope, it just shows at 1. In Python, you can do that. Python is probably a more robust way to do it, but it could be overkill if you're yeah. So like this is good because speed at scaling things up every little piece of speed can be important. So, all right, the username is the first field -f1 parameter of the cut command, and the /etc/password file uses colon as separators -d colon parameter of the cut command. We just pipe the output of the grep command to the appropriate cut command. Okay, perfect. So that's the answer to that guided exercise. So let's try to do the other one again now that I know those pipes are fair game. So we're going to figure out how many users and groups exist in your system. Okay, so we know that from the reading, we know that so we're going to match on any character any number of times. Then we're going to cut based on do a cat there. There we go. So now okay, so now we're going to list only the first line. Oh, sorry. We're going to see how many users and groups exist on my system. So one of the ways we could do that, if we know that the, if I just cat it out, we can see the fields there. So we know that the 1, 2, third field and fourth field are what is important to us if we choose the delimiter as the colon. So we can do that. Pipe wc-l, and we've got 34, and then we can like take a look at the fourth field, and we've also got well, actually no, this doesn't work because we need to know whether they're unique or not. So yeah, I'm curious about this. Well, I'll look at the example, or I'll look at the answer, because I have a feeling it's really complex SED, which I'm really not in the mood for right now. Hopefully I'm in the mood for it on the test. Alright, so how many users and groups exist in your system? Remember, use only the /etc/password file. The first file of any given line in your /etc/file is the username. The second is typically an X, indicating the user password is not stored here. It is encrypted in the /etc/shadow file. The third is the user ID, UID, and the fourth is the group ID, GID. So this should give us the number of users. Okay, so let's get the number of users here. Cut -d. That's our delimiter, is a colon. We want the third field. Okay, so actually they are using the same strategy as I am, but you know, you're just gonna get you're not getting the number of users, right? You're just getting the lines in the file. So it's like you need to know whether they're unique users or not. Like 34 is just the number of lines in the file, so unless, you know, maybe it doesn't list the same user twice, but I'm pretty sure it does. Let's ask the AI. Will the etc password file ever list the same user twice on multiple lines? Okay, so there are no duplicate entries for the same user. Each line in the /etc/password file represents a unique user account. And the username field must be unique. So duplicate entries for the same user are not allowed. Okay, perfect. So the answer is 34. All right. So, well, most of the time it will. However, there are situations where you will set different super users or other special kinds of users sharing the same user ID. So to be on the safe side, we will pipe the result of our cut command to the sort command and then count the number of lines. Oh, you know what? that can be a problem because we can have, even though we have a different name, we can have the same like ID for the user for some reason, some way, somehow. I'm trying to find an example of that. Probably easier if I do it with the filter. There we go. So this should, I don't really see anything like that. Should be pretty easy to identify. Huh, I don't really see anything like that. So let's ask the AI. Okay, so this statement suggests that in most cases the user ID will be unique and assigned to each user individually. This is generally true in standard user management systems, as user IDs are typically used to identify and differentiate users. However, the statement also acknowledges that there can be situations where multiple super users or special kinds of users may share the same UID. Okay, so let me ask it, show me an example of an instance where show me an example of a situation where multiple users share the same UID. So I have a feeling the first part would still be okay, but actually show me. Okay, great. But actually show me what the Etsy password file might look like. Okay. Here we go. This is exactly what I'm looking for. So yeah, you can see. Okay, so here's an example. Web user and web user 2. So in this example, both web user and web user 2 have the same UID as 1000. This means they share the same numerical identifier for the user account, but they have separate login shells and home directories to differentiate their individual settings and files, which sounds like a good idea from a administration standpoint. Like if you have a series of like outsourced contractors or like something like that, you just make one user ID account and set them all up with it, and then if you want to deny them all access, like, or like, you know, do something, you can condense it down to this one account. If anyone needs a special account, team lead or something, you make it for them. Like, that sounds like something you could see a lot. But however, it is important to note that while sharing UIDs is technically possible, it is generally not recommended for regular user accounts. Sharing user IDs can create confusion, security risks, and difficulties in tracking individual user activities. Yeah, so it's probably a bad idea. Let's say, what about a situation where you hire contractors to work on your system? Are there any advantages to having them share to having their accounts on the system share a common UID, or is it always better to have each account assigned to a unique UID? All right, so let's see here. So while there might be administrative conveniences for using shared IDs for contractors, such as simplified user management, These advantages should be weighed against the potential risks and security implications. Assigning unique UIDs for each contractor account generally provides better control, accountability, and security measures within the system. When hiring a contractor to work on a system, it is generally better to assign each account a unique ID rather than sharing a common UID. So this is the big one. I've definitely experienced this. Accountability and auditability. You want to see what people are doing, and then you want to be able to see that in a really granular way, and not just not be able to see a problem coming. You don't want to be blindsided by things happening on the system, so you need to track and audit activities in a granular way. You won't do that if you share UIDs across accounts. And then access control too, just having a you can have different levels of access, unauthorized access, especially if there's like one password ID just for that. Like, you want to see if an account is going rogue, and you want to be able to host that account as soon as possible. If you've got everyone on the same UID and all you can do is host that whole UID, you're going, just because one bad apple's in the bunch, you have to throw the whole bunch away. So definitely not a good idea to share UIDs. But if you're on a system, it might be necessary to see if that is occurring and see all of the users that are unique. So to do that, you can do what it says in the answer key. So we can do this cut on the file, and then we can get the count to see how many there are. There are 34 entries, but now we can add the sort as well with the -u for unique. And we still have 34, but if you see it decrease on systems, and if you have hundreds and hundreds and hundreds, thousands of accounts, this is really useful because you can identify really fast if this number shrinks, if there is non-unique user IDs, which it's probably a good idea to resolve that and get each person on their own account, unless you have like 10,000 accounts, which could be possible depending on how big the company is. But with scripting, with all that, it shouldn't be too bad. So when it comes to user groups, we do have a large number of duplicate groups. I would say, 34 minus 28, so that would be 16 user groups that are non-unique. Okay. Or is that 8 that are non-unique? I think it's 16. All right. So how many users and groups are in your system? So the next line is okay. So there we go. We did this to get the word count in there. So most of the time it will, however. So this should give us the number of users. Most of the time it will. However, there are situations where you will set different super users or other special kinds of users sharing the same user ID. So to be on the safe side, we will pipe the result to our cut command to the sort command, and then count the number of lines. So there we go, sort to get them unique. We did that. And then with the number of groups, there we go. We had no non-unique users, but we had plenty of non-unique groups. All right, so list only the first line and last line. I think this is the next one. Yeah, so on to the next one. And you know what? I unfortunately do need to stop. Well, let me just finish this out. So list only the first line and the 10th line in your file. So we can do head. You know what? I'm going to come back to this and do a proper. I'm just out of time. So I will put this in like this. All right, and then make sure that it actually does what it says it will, which is always a question. Okay, and then I'll come back to part 4, close out these guided exercises and hopefully close out the explorational exercises as well, and then move on to the next one, 103.3. All right, thanks for watching and see you in the next one.